Now, using the tiles is a really great way to build understanding for solving equations, not always a practical way. So what I'm going to do in these next examples is show you how to solve them algebraically, and it's still using the balance method, but now we're going to show that we're still doing the same thing to both sides. In example 1, I have n minus 15 is equal to 32. I want to have the n all by itself. That's my goal. But I have this minus 15 here. So to get rid of the minus 15 on that side, I have to do the opposite operation. So it would be like me adding 15 plus tiles. If I do that on the left side, I have to do that on the right side, because remember, I have to stay balanced. So what we're doing is using the opposite operation. This is subtracting, and the opposite operation is adding. So I do that to both sides. Now, minus 15 and plus 15 makes 0. So I can cross that off, and I'm left with just the n, which is what I wanted. And then on the right-hand side, I can add 32 plus 15, and that is equal to 47. And that's my final answer. In example 2, I have x plus 13 is equal to 10. So I want the x by itself. I have to do the opposite of plus 13. So that is minus 13. And I need to do that on both sides because I have to stay balanced. Now, plus 13 and minus 13 make 0. So I can cross that off. I'm left with, on the left, x equals, and then 10 minus 13 is equal to negative 3. It is okay for us to write this with the x on the right-hand side. We still follow the same concept. I want to get the x by itself. So that means that I need to get rid of this, the 5. So I have to do the opposite. This is a plus 5. So I have to subtract 5 on my right side, which means I have to subtract 5 on the left side. This is a positive 5 minus 5. That makes 0. So I can cancel that out. And on the right-hand side now, I just have x. On the left, I have 4 minus 5. And you can put that in your calculator, or maybe you just know. That equals negative 1. And that's finished. For this example, I have 6 times n is equal to 18. So the operation that's here is multiply. The opposite operation to multiply is divide. So what I need to do now is to divide both sides by 6. I'm going to divide this side by 6, and I'm going to divide this side by 6. Now, I don't usually write it like that. I'm going to show you how I write my divide by 6. What I do is I go like this and make it divided by 6, and I do that on the other side as well. So now we know that 6 divided by 6. Now this time, 6 divided by 6 does not equal 0. 6 divided by 6 is equal to 1. That means on my left side, I have 1n, which we can just write as n. And on the right side, 18 divided by 6 is equal to 3. In this example, I have m divided by 14 is equal to 70. Well, the opposite operation to dividing is multiplying. That means that I need to multiply this side by 14 so that I can get rid of the divide by 14. That means I have to do that on the other side as well. I have to multiply by 14. Divide by 14 and multiply by 14, they cancel each other out, but they make 1, not 0. So on this side, I have m equals, and then 70 times 14 is equal to 980. Sometimes you'll see me write a question that is a divide like this. M divided by 14 is equal to 70. You do it the same way. It's the same question. You just multiply. So you'll see me do this to show that I'm multiplying both sides by 14. And then, again, the multiply and the divide cancel each other out. And you're just left with m is equal to 980. I'd like you to pause the video right now, write down these 3 questions, and try them on your own. When you're done, come back and play the video to check your answers. Welcome back. Now, the first one, we have 5 multiplied by x is equal to 20. The opposite operation to multiply is divide. So we are going to divide both sides by 5. The multiply and the divide cancel each other out. We're left with x is equal to 20 divided by 5 is 4. In question 2, we have x minus 7 is equal to 11. The opposite operation to minus 7 is plus 7. So I have to do that on both sides. Minus 7 and plus 7 is equal to 0. So that's gone. And I'm left with x is equal to 11 plus 7 is 18. In question 3, this time I'm dividing by 3, and I need to get rid of that. So the opposite operation to divide by 3 is to multiply by 3. And this is how I show multiply by 3, and I don't have a lot of room on this side, so I got to squish it on there. Multiply by 3. Multiply by 3 and divide by 3 cancel each other out and make 1. So I'm left with x is equal to positive 3 times negative 5 is negative 15.